So in 11.4, we are going to talk about the area of some more polygons. This time we're going to look at kites, rhombuses, and squares. By the way, I looked up the plural of rhombus, and it could be rhombi or rhombuses, so I just chose to write that one in. Okay, so what is the definition of a kite? It's a quadrilateral, which means 4 sides, with 2 sets of congruent sides that are equal. So in this kite, the 2 sets of congruent sides, this side and that side are congruent, and this side and this side are congruent. We've got 3 facts to write in. I'm going to go ahead and type them in. You'll want to pause the video to write them in as soon as here in just a second. All right, so the first fact about a kite is that the diagonals are perpendicular. So diagonals are going to connect opposite vertices like this, and the fact that they are perpendicular means we are going to have right angles there at the center where they intersect. Our second fact is that a kite can be divided into 2 isosceles triangles with a common base. So if we look at the kite and kind of keep a lookout for triangles. So we have this top triangle with 2 congruent sides. So that's your isosceles triangle. Then we have this bottom triangle with our 2 congruent sides. The base that they share, we're talking about that base right there. You can see that that is the base for each isosceles triangle. So knowing that we have isosceles triangles is helpful information in some of our examples. Our third fact is that the area of the kite is going to be equal to the sum of the areas of each triangle. So if you knew the area of each triangle, you could add those 2 together to get the area of the kite. All right, there is also a kite formula. So you can see there's our A for area, and then it says kite really small in the subscript. So the area of a kite is equal to 1/2 of D1 plus D2. Now you might be saying to yourself, well, what's D1 plus D2? D1 and D2 are the diagonals of the kite. So D1 is going to be this diagonal. So I kind of put it over here. It's going to go from the top to the bottom of your kite. That is D1. D2 is going to be the other diagonal. And it doesn't matter which one is which. So from here to there, that is D2. So the area of our kite is equal to 1/2 of the sum of your diagonals. All right, so moving on to rhombus. A rhombus has 4 equal sides, and it's a special kite with all the sides congruent. So that means that your kite properties will apply to a rhombus as well, only this time we have all sides congruent. We've got 2 facts to write in about a rhombus. So here's your first one. The diagonals are perpendicular. So that's probably not surprising since the diagonals of a kite are perpendicular as well. So we can go ahead and put in that right angle. We know that that's going to form a right angle right there. And our second fact is the diagonals bisect each other. So what that means when the diagonals bisect each other is that it's cutting the diagonal into 2 congruent parts. So, for example, I know that this half of the diagonal will be congruent to this half. And then for the horizontal diagonal, that is going to be congruent to that. We've got a nice little area formula for the rhombus. Area is going to be equal to 1/2 of, now it's not, okay. Haha. I told you the wrong area formula for a kite. So area of a rhombus is diagonal 1 times diagonal 2. So if you multiply your 2 diagonals, and again we've got diagonal 1 goes from here to here, and diagonal 2 is going from here to here with inside the diagonal. It's just getting sloppy in there, so I'm writing it out there. So right now on your kites, just go look up on your page. This is the same area formula for a kite. I told you to add the diagonals and it is multiplying, so please make that change right now so you have the correct formula in your notes. So last we have a square. A square, we know what it is, but sometimes it's nice to know the technical definition. It's a quadrilateral with 4 equal sides and 4 right angles. So that means our 4 sides are congruent, and then we have 90 degrees at each angle, so 4 right angles. And it is considered to be a special rhombus with all right angles. So when we're looking at a square, you can label each side with an S. It's not my favorite variable to use in math, but that's what's used here. So to find the area, we're just going to do, your base times height. And because it's S times S, we just write S squared for the area of our square.